You guys wanted me to make a video on multiplying and dividing exponents, so in this video we are going to do just that. But first I want to get some facts straight. So let's first talk about variables. Variables have the word variable because unlike constants, like 2, 3, 4, or 5, which are always the same, variables can be assigned to different values and they thus vary. For example, x can mean 2 or it can mean 3, y can mean 4 or it can mean 5, and z can mean either 3 or 4. It doesn't have a specific value that is associated with it. You can think of them as just placeholder values. Another thing that I want to talk about is what is a base and what is an exponent. So an exponent, which in this case is b, is the number of times that the base is used as a factor in repeated multiplication. It is the number of times that the base is being multiplied. And so if you had a base of 2 and you were multiplying it 3 times, the exponent would be 3 because that is the number of times the base is being multiplied. Then for the base a, the base of a power is the expression that is used as a factor in repeated multiplication. It is what is being multiplied. So in sample of 2's, you have the 2 just being multiplied 3 times, and so it is the split base. Okay, now we will talk about the actual trick
dividing
of
exponents. So let's just start with the first rule. The first rule says that if you have powers with the same bases but different exponents, you can just sum the exponents up to find the total product. So say for example, you have 2 to the third power times 2 to the fifth power. What would the total product be? Well, we can just add the exponents, 3 and 5, to get 2 to the 8th power as our final result. So that's just finding the product of 2 powers with the same base but different exponent. But now we'll look at trying to divide these 2 powers. So if you were to divide 2 powers with the same base a but different exponents c, b, and c, the final result, or the quotient, would be a to the b minus c. So instead of adding, like you did when multiplying the powers, you subtract the 2 exponents. So that's just the very first rule. Now we'll talk about the second rule of multiplying and dividing exponents. So say you have, instead of having the same base with different exponents, say you had the same exponents with different bases. So we have the same base, the 2 b's here, but we have the different bases. So you have the a and you have c. So if this was just, if there wasn't a c here and there was an a, we could just have 2 times a to the b power. But because we have a c here, then we have to use a special rule. The special rule says that you can just multiply the 2 bases, so it would be a times c, and then have that to the b power, and that will be your final product. See, a to the b power times c to the b power equals a times c, that's their whole base, to the b power. Then you can use an example of this, so it could be 3 to the 4th times 2 to the 4th power. Well, you just multiply the 2 bases to get 3 times 2, and all that to the b power, and the b here is 4, so it would just be 6 to the 4th. Okay, we can do a similar thing like that for division. So 3 to the 4th over 2 to the 4th would just be 3 over 2, all that to the 4th power. So instead of multiplying them, like we did with multiplying the exponents, you simply divide them when it comes to division. Here's another rule, that if you have a to the b power and then all that to another exponent c, so just be a to b to the all that to the c power, then you just multiply the 2 exponents to get b times c. And so an example would be if you had 3 to the second power, that to the 4th power would equal 3 to the 2 times 4 power. And we all know 2 times 4 equals 8. There's another rule that says that a to the 0 power equals 1, so if you have 0 as your exponent, you will always get 1, except if this a is equal to 0, because then you would just have a 0 to the 0 power, and that is an error that isn't possible. And so 2 to the 0 power equals 1, 3 to the 0 power equals 1, 4 to the 0 power equals 1, everything to the 0 power equals 1 besides 0. Here's just another simple rule that if you have something to the negative 1 power, it would just be the reciprocal. You may be wondering, well, what is the reciprocal? That's just when you have 1 over that something. So in this case, a to the negative 1 would equal 1 over a. That's the reciprocal of a. It's just a fancy term. Also, a to the negative 2, that would equal 1 to the a over 2.